Hello again. This is part 2 of solving systems of linear equations by substitution. In the last video, we kind of went in depth and talked about checking answers, talked about what the solution to the system means, and I showed you a relatively simplistic example. In this video, I want to just show you 2 more examples that maybe look a little bit different from the original question we used and make sure that we have an example in video for how to do that. All right. If we look at this system here, this y equals negative 3x minus 1, and then 4x plus 7y is equal to 10. The first thing that should jump out at anyone making any attempt to understand this is, well, both of these systems are not equal to y. Right? Back up here in our first equation, our first system, we had both of these were equal to y, and that made it really easy to write an equation and solve for x. In this case, we don't have that. We know that y is equal to negative 3x minus 1, but down here in the bottom equation, well, y isn't equal to anything, right? Y is part of the equation, and that kind of breaks the pattern we were seeing in the last question. This isn't as scary as it looks, and let's show you why. The first thing I'm going to do is I'm going to take this top equation, and we're going to color it. I'm going to call this the green equation, just so we can see how this substitution is working, all right? So I'm going to rewrite, just start from fresh. Use this bottom equation. We have 4x plus 7. Now, when I get to the y right here, instead of using the y, I'm going to substitute in what I know y is equal to, all right? So I'm going to open some parentheses, and I'm going to plug in what I know y is. Y is equal to negative 3x minus 1. Close those parentheses up and write the rest of the second equation. Just like that, without any extra math, it's actually, some consensus is even easier than the first one. You just have to take the data that we have. We're told that y is equal to negative 3x minus 1. We just put that in here, right? We just say this whole thing right here is equal to y. Therefore, we plug it into the second equation where we have y. Done. All right. From here, you just need to remember how to use the distributive property and solve. So we're going to say 7 times negative 3x is going to be a negative 21x. 7 times negative 1 is just negative 7. And then we just bring down all of our other leftovers from the previous equation, the 4x and the 10. And just like that, we have the parentheses gone and the nice simple equation to solve. I say simple, you might disagree with me, that's your option. All right, the first thing I see is that there's a 4x and a negative 21x. Those are like terms, right? They're both just piles of x's. We have x negative 21 times and we have x 4 times. And so if we were to mush those together, if we were to add those together, we'd be left with a negative 17x minus 7 equals 10. So far, so good. This is getting pretty simple. I think you should be able to see it by now, but just to be on the safe side, I would bring this 7 over by using its opposite. So positive 7 on both sides of the equation. That would give me a 17 equal to a negative 17x. Things are starting to look pretty happy here, pretty easy to get solved. We can divide both sides by negative 17. Negative 17. We're left with a negative divided by a negative is just a positive 1x. And a positive divided by a negative right here is going to be a negative 1. So far, so happy. From here, we have our x value. We can plug it back into our equation to get our y value. So let's just use this green equation from the beginning. Y equals negative 3x minus 1. And substitute in our x value. So we have y equals negative 3, except that we know now that x is negative 1. So substitute that in. Right? This comes right from here. And then we just evaluate. Negative 3 times negative 1 is just a positive 3. Bring down our negative 1. 3 minus 1 is 2. Now we have an x value and a y value, and we can write them as a ordered pair. So we have negative 1, comma 2. box that in, and that is our solution. And just a reminder, we can go over, we could plug those back in, or we could come back over here to Desmos, where I have those two equations graphed, and we can see that they do in fact intersect. Those two lines of the equations intersect at -1, 2. We're good, we got it right. I'll remind you, I'm going kind of quickly here because it's a video and I don't want to bore you to death, but please make use of the pause button if you need it. You can always come back, rewind. I believe YouTube even has a slow feature. You can hear me in slow motion. If you really want to go there, you can do that. All right, last one and then I'll get out of your hair. This is question 1 on the second sheet, if you're curious. This one's a little different. We notice right off the bat that I don't know what y is equal to, and I don't know what x is equal to, right? At least in this last question, I could say, well, at least y is equal to -3x minus 1, and I could substitute it in. I can't even do that here, right? I have to do a little bit of work before I can even start actually solving and finding the solution. The way I'm going to do that is I'm going to algebraically rearrange one of these two equations in the system to get either y by itself or x by itself. Now, in this case, and I can't really tell you how to notice this, except that I think you can see in this top equation, y is already kind of by itself, right? It has no coefficient. It does not have a number in front of it like it does in the second equation. That's your hint that y is going to be the easiest thing to get away and isolate by itself. So let's just do that over here. We're going to rewrite the equation to x plus y equals -20. And then we're going to just we're going to tag this y for isolation. We're going to get it by itself. We're going to do that by subtracting 2x from both sides. Now, right, positive 2x minus 2x leaves us with just a y on the left-hand side. Now, -20 minus 2x, most of you are screaming at me right now, well, you can't do that, right? They're unlike terms. You cannot subtract 2x's from a 20. That's not a thing. So that's true enough. Just rewrite it in a friendly way. -20 minus 2x, you're done, right? We didn't actually have to do anything. We just were able to rewrite it. Now we have y equal to something. We can actually move on. Real quick, I'm sorry, the buses are starting to get here. You're going to hear all that racket in the background. I'm not pausing because I don't want to redo this. All right. So we have two of our equations, and just to help us out, it might make sense to rewrite these. So there's the bell. Might make sense to rewrite these over here as part of our original system so we have something we can work with. So our original system had, so get that one, bring it down. There we go. We have y is equal to -20 minus 2x, and then 5x minus 5y is equal to 10. I really could have picked a better time to do this video. All right, so now from here, it's just like the last equation, like the last practice problem, right? You're going to plug in, you have this green equation right here. There we go. And you're just going to substitute it into your other equation, 5x minus 5, except we plug in y, we plug y in right here, so -20 minus 2x. And that is equal to 10. And from here, you can just go through all the steps that you did in this last problem, right? You can distribute the -5 over the -20 and the -2x. That'll bring you down. You'll get an answer you'll get x equal to something. In this case, I'll leave it to you. You're going to get x equals -6. And then you'll use that, right? You'll plug that x equals -6 into your existing equation, right? That y equals -20 minus 2x. You'll plug that in, so you have y equals -20 minus 2, and you'll use your x value. And then you'll solve, and eventually you'll find that y is equal to -8. Again, I don't really want to solve this for you. You have an example of how to do this, and I'd like you to work on it yourself. All right, I hope that helps. There will be one more video, not today, but one more video just on another slightly even more complex problem than this, and then we're done.